Hi everyone, I hope you are doing well and you enjoy the last few hours of the conferences. Today I'm here to talk about native module and a Rust native module with Node API. First thing first, if some of you were already checking other video from the previous, let's say, Node.js conferences or stuff like that, you have to check. You definitely have to check it because it's really a lot of evolution about what's a native module with Node.js. And also it has been a talk which mostly have been not done, but some part of it were done in pretty much every year. So that's quite nice to see how it evolved in the past like 8 years. So that's great. And also why Rust native module with Node API. I could have named this talk something else, like writing low-level stuff with a cool language and binding it with Node.js could have been also a good name. Not sure the community would have accepted that, but it's an acceptable name also. Yeah. So who I am, I'm Jean Burellier. I'm a French guy, as you most certainly hear it. I'm not a native English speaker, but should be good for at least 20 minutes. You can find me on pretty much GitHub, Twitter, and Twitch also a little bit. If someone also is working at Twitter or know people working at Twitter, I'm trying to get back my name on Twitter, so yeah. So DM me if you work at Twitter, yeah. And you will find me working mostly on a Node.js initiative on the next 10 with other people trying to improve the next 10 years of Node.js. Maybe some of you already listened to the conference and the talk given by Michael yesterday, I think. So I'm part of this group and also jumping from group to group from time to time. Okay, great. So why are you here and so what's the agenda? First, why do you want to use native code when working with Node.js? Node.js is great. You are writing JavaScript code. JavaScript code is running from browser to smartphone to backend. You can also deploy your own architecture with it. So you can do pretty much everything. So why do you want to go back to low-level code writing C or C++ or Rust stuff? We'll also see how we can interact with the native module and the interaction between native code and Node.js, and also a small example on Node API and how we are able to leverage Rust to, let's say, try to optimize our code, but still keeping most of the big logic on the Node.js part, and why sometimes it's great to do so and sometimes it's not. First, I think it's quite, I had to add this slide. It's a slide which is always on when someone is talking about Node.js add-ons. So add-on are dynamically linked shared object written in C++. So that's one part of it. You also have the require function can load add-on as ordinary Node.js modules. And add-ons provide an interface between JavaScript and C++ libraries. This is directly from the Node.js documentation. I think it has been the same based explanation on what's an add-on for the past 10 years. So I hope it will keep the same for the next 10 years also. It's pretty good. So first, I don't know if some of you are mobile developer or writing hybrid or native code using maybe different kind of stuff like Ionic or stuff like that, but pretty much every time you are writing code which is not the same or the expected code as the final platform, so could be mobile or anything else, you will have to handle a bridge, which is basically a way to interact between two different languages. And this bridge is quite inefficient most of the time, as you will have to try to work with, from one side, JavaScript or Node.js object or data, and on the other side you will have C and C++, we do not have the same type system between all languages. So every time you will try to access some memory or some information from one side to another, it's not just getting the information, but it's also parsing the information and being able to read it and to understand it for your language. Okay, that's one part. And one of the key points of writing Node.js add-ons or pretty much everything is why do you want to not just write pure Node.js? Because we already wrote Node.js for, let's say, basic REST API or stuff like that, but also for more heavy real-time application. So it can handle a lot. But from some time and some really key point of technology or stuff you really want to do, you need more performances. You need to be able to process a lot of information or to work on heavy file, heavy data stream, pretty much everything. It can be about image and video processing, which is, for me, every time someone is talking about, I have to handle large file or pretty much everything, it's always, let's say, 4K images or maybe a 20-minute stream record or something like that. It's also about compression. I don't know if some of you already tried to work with compression with, let's say, JavaScript. It's quite, let's say, easy to do so when you work with Stream, but it's not really optimized, or at least you do not have the same optimization as you can find in other low-level languages. And it's also linked to CPU-heavy tasks, as you pretty much, I think, aware, Node.js rely on the event loop and a non-blocking I/O. So we can have some issue with that. And the last part would be, but it's also linked to the CPU-heavy task, to the math, every math, let's say, scientific calculus issue problem, or if you want to work with non-standard kind of number. I was thinking about big int, but now we start to have them in Node.js. And let's say even in JavaScript, but still it's not the same way to work with them across the full ecosystem. And also, historically, we all use, let's say, low-level languages like C and C++. If you go to a lot of company, I'm thinking about maybe banking solution or insurance company, when they try, because it's also running on all software, it was mainly built with C and C++ because of the performances, and the performances of this language are better than JavaScript most of the time. So one key point on why using Node module would be to use for performances, but that's not the only one. Let's say it's the first one. Another part is, like I said, maybe your company is already using some, let's say, on-premise server which handles some critical task or really just business-oriented task, which is the same way they are doing it for the past 10, 20, 30 years, something like that. So maybe you already have a code base in your company which is written, let's say, in C or C++, and you don't really want to rewrite a full code base on this old project because it's working and you know it's working. So how can you do that? You can also, with this Node API, you can also reuse already existing code base. It's way faster to integrate because you do not have to rewrite something else, and it's also an easy way to just expose some functionality, because with Node.js it's quite easy to just have let's say, an easy way to provide, let's say, a REST API. But if you are working with just C or C++, writing a full web server, or if you try to allow people to just do some requests to your system, you will need to have multiple bridges from HTTP to your own internal system or stuff like that. Here you can just take your C++ library, you put it in an add-on or Node module, a native module, sorry, and you just hope that your customer will be happy to use it. So that's pretty good. And also, sometimes, just basically because the feature is not available. We do have a lot of packages on NPM. I think I just saw a tweet a bit earlier today. We do have more than 2 million different packages on NPM right now, or maybe more, but maybe I'm wrong, but I think something like that. Yet, we do have a lot of multiple packages or some library which are still doing the same way, and it's just the same way to implement multiple, yeah. It's just multiple packages implementing the same solution. But also, for some part, we do not have a good way to work with some tasks because it's not something which is really used as a front-end development, or we do not use it a lot as a back-end development because of performances or other key points. So that's really one part. For example, maybe if some of you were working with, let's say, machine learning or intelligent artificial stuff, I'm thinking about TensorFlow, but it can be also a lot of other tooling. Also, if you want to work with more compute-intensive library, I'm thinking about multiple examples, but image or video processing stuff like FFmpeg. I'm thinking also about ImageMagick, which is one which is quite used for a long time. But also because sometimes you do not really have a driver or at least an easy way to access some kind of hardware. I think a few months back, NVIDIA released a way to use and to access GPU from Node.js or at least JavaScript. But it's quite new, and I'm not sure that you are able to do that or to do the same thing if it's not an NVIDIA card. So you are still blocked. Also, we start to have more powerful way to do computing. I'm thinking about custom hardware to do math or to do machine learning stuff. So yet, it would be possible for you to write a Node.js library, or let's say just basically a JavaScript library, but is it really useful to not use the base languages to access it? And it really depends. But for me, I try to not write code when I don't really need it. I just want to reuse something which is already working. So having fun writing a GPU Node.js library, maybe it can be interesting, but I don't really have time for that. If you have time, let's go. But I don't really have, yeah. So yeah, basically, most of the time we really want to concentrate on working on business logic and something which will help our customer or at least a company we are working with, and not just spending time rebuilding or reinventing everything pretty much. Okay. You also have some other edge cases for some access to really low-level API, which are not already included in the Node.js, let's say, core system. I'm thinking about system call or stuff like that, but also with desktop app, like with Electron or stuff like that. It's quite easy, and now it will be a good way to, when you are writing a desktop application, to just be able to easily access, like I said a bit earlier, GPU or stuff like that. Okay. I think you know some of, maybe all, but some of this library, which are good example of add-ons. So Node Canva, Node Sass, I think this one at least, pretty much everyone used in one time Node Sass, and you had a lot of, what was a common error when using it? Node GIP, try to compile, but everything crashed, and you are just stuck for the next week because you are waiting for some kind of update from some teams, and still it's working on some computer, but not others. So yeah, but yeah, it's just basic example. You also have, I'm thinking about other library also, like Bcrypt or stuff like that, like low-level stuff. And also, one key point of that is, thanks to the add-on part and the way to build add-on and to link that to Node.js, you can write and use C++ modules which are completely hidden from your consumer, from your user. This means for them, it's just importing a module and use it, and they will just use it as another Node.js module or stuff like that. If some of you checked Node Sass maybe 2, 3, 5 years ago, you never had to learn C or C++ stuff. You just had some easy way to access functionality. So yeah, it's pretty great. But because nothing is perfect in this world, would be great, but it's not. Writing native extension requires a lot of knowledge on multiple parts, on libuv, V8, also some Node.js internals, because you will be trying to bridge between your JavaScript and your C++. It can also be if you want to access other low-level API. I'm thinking for Node.js, maybe OpenSSL or stuff like that. It's not directly accessible, or we don't really have a direct binding for it, so you will have to just try to see how you can do it. And also, I'm a JavaScript developer for the past, let's say, 8 to 10 years, something like that. I did learn to write some C and C++, but I don't know for you, but it's not the best syntax for me, or yeah. It's not the way I prefer to work with when I'm working and writing some code. It's just a basic example of working on just writing a basic header word add-ons, let's say. I won't really go through everything, but you have the include, which is the same as the require. You will find the void hello world function. You will have the tag on multiple places, the V8 double dot, which is just the access to the namespace, to the V8 namespace, because it will be a library, an internal library. And basically at the end, you will have both the initialize and the node module, which is, let's say, the way to export a module like we do a module.export in JavaScript in Node.js. You also have a custom way to build it. I won't go through a lot about that, but it's quite, let's say, easy to do so. You just have to hope that NodeGip is working for you. I tried to rerun that code yesterday. My NodeGip is now just dead, so yeah, not really working a lot. And also, at the end, if you want to, after you build everything, if you want to just use it in your Node.js application, you just need to require your module. You have two ways. You can just require with a full path of your release, or you can also use a binding solution to require that. Okay, so it's great. We are able to build a native and to use C and C++ in our application. Great. But we do have some issue. One of the key issue is Node.js is just evolve every day. We do have multiple releases a year, and a lot of interfaces also just tend to break. I'm talking about Node.js, but as you saw on the example a bit earlier, we are also leveraging an access to V8. So every time you do have a V8 change or update, maybe the interface definition will change and pretty much everything will break. And that's the main issue, is that it's really hard to continue to develop and work, because between just two Node.js version or two V8 version, it can break pretty much everything. So for that, an initiative started, I don't have the exact time, but I think it's 2012 or 13, something like that. And some people created a native abstraction for Node.js, so NaN. And yes, it's not a number also. I forgot to have I think I tried to add a slide and I completely forgot to add it at the end. Okay, so it's a third-party module at first. It was next included in the Node.js Foundation as a core project, because it was really useful to not just write basic add-on and have an issue to need to recompile everything and check everything every time you add a new version. It's provide a layer of abstraction. It's provide a layer of abstraction on top of the Node.js API, and basically it's provide and it gives you a common interface when you try to work with Node.js. It wasn't about everything. The first part was really about V8, because V8 is most of the time the library which is breaking a lot of stuff. So it was, let's say, one part. But you also have a big issue, is that when you try to write an add-on or something else, you have to take care about where your code will be working. Because we work with different kind of platform, architecture, compiler also. So you have to provide a way for everyone to be able to just run your code, to compile it, to build it. And that was still one of the issues with NaN, is that you had to recompile pretty much everything when you switch between multiple Node.js versions. So if you wanted to just build your software for, let's say, Node 6, 8, 10, something like that, you had to build it 3 times, and if you wanted to deploy it for, let's say, multiple architecture or, let's say, platform, maybe a lot more. So it was quite hard and really hard to maintain. Just a really fast example on of the same code as previously is that you just have your basic function. If you check that, we replace everything with a V8 word keyword by the NaN keyword because it was a layer of abstraction on top of it. So not a lot of other changes, a bit on the initialize part. As we can see, we start to use some keyword which can be more JavaScript than C or C++. But okay, it was great. And finally, we do have Node API, which is an initiative which started in 2016 and it was released in 2018, I think, if I remember right. And basically, the main point of so NAPI, which is now named Node API, sorry for the change of the name. The main point was really to be able to provide a stable ABI, so application binary interface. So it's just a compiled API of the system. And it was here to define and export C, type, and function, but not about just V8 or just one part of your Node.js or runtime or something else, but pretty much everything. So it was a full abstraction of the JavaScript engine. And also, a lot of work was done also implementing a better workflow to not just use Node.gip, but also CMake.js, pre-build, and other tooling solution, other system. So it was really something that pretty much a big part of the community wanted, because it was quite hard when you try to build some add-ons to have to rewrite them or to change them, to check them every time a new Node.js or V8 version was just pushed by some people. And Node API is really the answer of all this issue. And so, yeah, and the promises really about that is a full compatibility across different major versions of Node.js. And the Node.js team, but also the V8 team, is working a lot on keeping every, let's say, definition up to date for every version. So this way, it's fully retrocompatible. So you can just build something today, it will be available and working for the next major release or stuff like that. So because we kept a way to have the same, let's say, to keep the same interface, you don't need to recompile your module every time, so which is great. And also, it allows people to work with different engines than just the V8. I'm thinking mostly about ChakraCore, which also was not really possible before that. And NAPI, at first, with a pure module part, it was really about writing stuff with C and C++, and API really allow people to work with other, let's say, low-level or other languages like Rust and Go, because it's also something that is great about NAPI. It's because you just need to have an easy access, and everything will be done for you. And yeah. I had the title with the keyword Rust, so I have to talk about Rust, but to be honest, it's not really a full talk about Rust. We are in a Node.js conferences, so I'm mostly speaking about Node.js, but if some of you want to try to work with Rust, you do have multiple tools and multiple libraries which allow you to just work on and build a native module without spending a lot of time on configuration. So mainly Napi.rs, Node.bindgen, and Neon, which is the mostly known. I think you also have other solutions, but let's say it's the main part. And I think also a small demo on that. I plan first to have a bigger demo for you, but I injured my hand, so it's a bit harder to write. And yeah, I think it's visible for you. So basically, I took the easiest example on how to compute something which takes time, so basic Fibonacci. Nothing really special, just computing a Fibonacci until the 40th number, the 14th iteration. It's not optimized, no memorization, pretty much a basic worst case scenario, the worst one. And I want to just compute the same number 10 times, so pretty much it's not the best way, but it's just a basic way. And on the same time, I also have the same function written in Rust, which is pretty much exactly the same thing. I do have a while loop to iterate 10 times around my Fibonacci, and I also have my basic Fibonacci function. So that's basically the same stuff, and yes, it's not optimized, and yes, a lot of people already trolled that. So, okay, so let's see just the difference between the two versions. So on the right part, yeah, it's my Node version. I do have a console log on each line. I could have removed it, but it's not really the part which will change a lot because writing in nodes, it's quite fast, or at least comparing and computing everything, it's quite fast. Yeah, I think 5, 6, 10 seconds maybe.
Can you bump up the font, please?
Sorry?
Can you bump up the font, please?
Yep.
The font size?
Yep.
Thank you.
Yep. Okay, so for the pure Node.js function, to compute the Fibonacci, it took 22 seconds, something like that. And if I run the same with my Node API module, it should be quite faster, around 6 or 8 seconds, something like that. Yeah, 6.4 seconds, so a quarter of the time, approximately, which is quite nice when you want to work with heavy computing. So this way, this example is just a crazy example, but imagine you are working with 4K image or, let's say, picture of the Hubble telescope or stuff like that. It will be way easier to compute and you will earn a lot. It will be easy to work with that. Okay, so it was really a small demo and everything will be available. You also have a lot of examples which are available on the Node.js GitHub repository. And pretty much we are showing every time the basic add-on, the NaN version and the NAPI version. So you have pretty much everything you can check and see the differences between everything. And I think I do have 1 more minute, so just some tips and feedback. One big issue with working with NAPI or pretty much everything when you try to cross between 2 languages is a bridge. So try to not go through the bridge a lot of time. Try to send maybe a low amount of data from one way to other way or something like that. Try to optimize that. Also, like you said, like you saw, it's quite nice to be able to process every chunk of data, so that's great. Do not try to rewrite everything in Rust or C++ with native add-on. You can if you want to have fun with that, but I think it can be overkill on 99% of the time. Like if you try to write a native add-on to parse your URL or stuff like that, it won't be really useful because you will spend more time on the bridge part than on just parsing the URL, so it's not really cool. Rust is nice, so yeah. Rust is great. And also, I won't talk about that too much because we do have another conferences, but also you can check about WebAssembly, which is also a good way to use, can be Rust, but also other languages, and which can easily be linked to a Node.js, to your Node.js code. And that's all. So thank you, everyone. And I think we are on time. Exactly. Perfect. Thank you.